At the front end of the car's lower tunnel, we have boundary layer controllers. These structures are vertical and horizontal extensions that decrease the air input underneath the car. As we were able to conclude from virtual tests, the controllers reduce the direct impact of air with the front by directing more air upward into the sides. Such devices also increase the airflow over the car and thus increase the speed of the fluid and decrease its pressure according to Bernoulli's principle. Thus, there is a reduction of drag on the car. The structures responsible for controlling the airflow with vorticity coming from the front wheels to protect the rear wheels are called fairings. The air coming from the front wheels presents great vorticity, which generates air separation in that region. Considering Coanda effect, to reduce this problem, it is necessary for the fairings to have a smooth shape, so the air can adhere to it. We designed fairings that direct the air to the car's lower tunnel. This way, they control the airflow coming from the front wheels, accelerating it and preventing it from reaching the rear wheels.
In order to increase the speed reached by the wheels with the same energy, it is necessary to decrease the radius and mass. In order to do so, our wheels were designed with a diameter of 26.3 mm, the minimum measurement allowed by the regulations, added to a margin of 0.3 mm. In the absence of near or outer covers, large amounts of air can enter the wheels and create vortices. In order to avoid this problem, we developed covers coupled to the axle of the car instead of being fastened to the wheels. For this reason, they do not spin with the wheels, reducing the mass to be rotated. Another way to reduce mass is to choose a low-density material. However, low-density materials do not necessarily have lower friction coefficients. Like a Formula 1 car, the ones designed for F1 schools have no wheel traction, so a low friction coefficient allows the wheels to skid without spinning, which consumes less energy and therefore increases the speed of the car. After conducting track tests, we conclude that polycarbonate will be the best material for our wheels, due to its low density and low friction coefficient.